What is extensive and intensive property? See, there are two properties in thermodynamics that we study. One is intensive, other is extensive. What is intensive? See, intensive are the properties that are independent of mass or size of the system. If you have a system and the property is not depending on its mass or size, then we can call those properties as intensive properties. Whereas there are some other properties that depends on the mass or the size of the system that we call as extensive property. Okay, so what are the examples of intensive property? As you can see, pressure, temperature, specific property, molarity, and molar properties, right? In a specific property, we can have specific volume, specific weight, specific enthalpy, and specific entropy, anything. So these property does not depend on mass. Let me give you an example how you can understand this concept. See, if you have this object, let's say, and you divide it into two parts. So what you can see, if it had some mass m, then it will be now m by 2 and m by 2. It will be divided into m by 2, right? Now, if you just see here, so the mass is half now. But if you talk about density, will the density get half? No, it will remain same. So what we can say here, that the mass is an extensive property as it does not depend upon the size of the system, right? As we have made the system, divided the system into two parts, the mass has changed. So we can say the mass is an extensive property here. But if we talk about density, what has happened to the density? It is constant. So it is not depending on the size of the system. So density is same, therefore we can say it as intensive property. Similarly, if you talk about pressure, that will remain same for both the objects, right? Both the partitions that we have done. The temperature remains same. The temperature will also remain same, right? Or mathematically also you can see here the density is nothing but the mass and volume. So volume itself will get half, right? Volume itself will get half. So if I have divided my system into two parts, then mass will be m by 2 and volume will be m by 2. Still it will be m by v. So therefore also mathematically we can also say that density is not changing. But now there is a question that how we can say, if we talk about heat, what is heat? mcv dt, right? mc del T. So this mass, we could say that Q depends on mass. So we can say that Q, heat itself, is a extensive property. But this is not the case, because heat is not the property itself. Heat and work are not properties. Therefore we cannot say that whether they are intensive or extensive. They are not properties at all. If they are not properties, how we can say that they are extensive, right? So even though the formula suggests us that heat is directly proportional to mass, but it is not the case, because they are not the property, they are path function. Let me tell you few other example. You can see here examples of intensive property: pressure, temperature, specific property. Any property which you divide by mass will become specific property. If you divide volume by mass, then it will be specific volume. There are other examples as well you can see here, and you can analyze. And one more thing here, if you talk about energy, in energy we have two forms of energy: stored form of energy, and the one that is transit form of energy. So stored form of energy depends on mass, right? And the one which is the transit form of energy, that is heat and work, they are not property at all. And if you talk about resistance, resistance depends on length and area of cross section. Therefore we can say that it is extensive property. And there are other examples: velocity, viscosity, density, conductivity are intensive properties, and volume, mass, resistance are extensive properties. These are the examples that you could understand.